Hey everyone, we're going to get started with our panelist on the state of open source modeling. Peter Fairley is our host.
Thank you very much. Good morning, everybody. So my name is Peter Fairley. I am a science journalist. I'm based in San Francisco and also in British Columbia. And I've been writing about energy technology and climate solutions for over 20 years and had a particular soft spot for power grids and how they are modeled and designed and hopefully get cleaner. And this summer I wrote a piece for the IEEE magazine Spectrum about open energy models for planning and how regulators in the EU and in some US states are increasingly starting to demand use of open modeling by project proponents who are saying, give us money, or at least to require that, for example, utilities provide more access to tools or more transparency about their data to stakeholders. So that's how I got on the radar screen here and why I'm standing in front of you. And I'm not an energy modeler, so don't ask me questions about that, please. Anyway, we've got a great panel today. We've really worked hard to get a balance of and a breadth of different perspectives, including people who actually use energy models to do planning, and a regulator. So I'm going to introduce each of the panelists and give them 4 or 5 minutes to give a quick intro to what they want you to know, and then I'm going to start waving my hands and maybe my legs also as we get past 4 minutes, so we can have lots of time for a good interactive chat and lots of questions from you all. And let's see. So I asked each of them to tell me one thing that even their colleagues who are here today might not know. And as you'll see, there are some very unexpected alignments. We've got a strange concentration of automotive industry experience. And I'd like to stress that I'm not saying there's a conspiracy. We also have several PhDs from UC Berkeley, which is Stanford's arch rival.
Go Card! Go Bears! Go Bears! Go Card!
Again, I think that's notable, but I'm not implying anything nefarious. And we also have several energy modelers here who, but by the grace of God, might have ended up as journalists like me. So without further ado, our first panelist is Priya Sreedharan. And come on up. Or do you want to just speak from there?
I think I'll just sit here. How's the sound? Good. Sounds good from here. Yeah, hey everybody. I work with GridLab. Just maybe raise your hand if you've heard of GridLab before. Yay. Okay, so about 2/3. We're a nonprofit organization. We're based right up the road in Berkeley, where the other school is. And we basically work on trying to support an affordable and a reliable electricity sector, energy transition, but focusing on the electricity sector. We work in 2 modes. One of the modes is really getting in the trenches in regulatory proceedings and supporting different interveners, environmental groups, sometimes state agencies. We also do different kinds of studies that sort of lead the industry sort of thought leadership on both bulk system as well as distribution system issues. In our activities, so why are we even here? Why do we care about open source modeling? We have found that in the various engagements in regulatory proceedings that transparency has been an issue, access to models, modeling assumptions, et cetera, has been an issue. We're often working with people who can't either afford to procure a commercial license tool to do their own kind of modeling, or they just don't have the capacity. And so we see open source modeling tools, and the data sets as being one way of sort of democratizing energy modeling. And that's why we've been involved with this. A couple years ago, my organization and another one called RMI, my colleague Aaron Schwartz is in the audience. He just raised his hand and said hello to everybody. We led an initiative called, it's an eLab initiative where you bring a bunch of people that have different views and you throw them together and help them to solve a really difficult problem. And I'm actually here to give you some insights into what we learned from that activity. We brought people like Anna Maleva, who's developed GridPath, folks that have regulatory perspectives, folks that are have the user sort of perspective. And we tried to figure out what would it really look like for an open source sort of initiative to really scale up our use of open source models in the real world. We know it's used in academia quite a bit, but what would it take to really make it work in the real world? And so what we did was we brought us all together, and it's interesting because early on we could align on this idea, a couple points. One, that both open source tools as well as commercial tools, they have limitations. Those limitations in terms of the technical features, and there are different limitations in both categories, but effectively the point is that we're not at the place where we have the toolkit we need to really support the energy transition. We also aligned on this notion that open source modeling could bring value to different stakeholders. It's valuable to regulators, or it can be valuable to regulators if they're interested in really sort of supporting increased transparency. There could be value to developer users, like, is the hand being waved?
Starting.
You're starting?
My arm is itching, but go on.
So it could be valuable to utilities, especially, there's a cost of an advantage in terms of, no license fee. And it could, and also if they're, open source tools are bringing features that are not typically available in commercial tools. But there are a lot of problems to really making open source tools, be a reality. So the value proposition is there, but what are the barriers? One of the barriers is, of course, a lack of a viable business model. Another is trust, and that's pretty self-explanatory. Trust and credibility is another thing. So a lot of decisions in our space are made by, folks that have different levels of skill sets, and also a lot of decisions are made based on what decisions other people are making. Right? So there's a lot of risk, and it's a risk-averse industry. So there's a lot of risk to taking on some new tool that nobody else has used or used in a regulatory context. How can you trust it? How do you know that it's going to give you the answers that, are reliable? So that's a big issue. Unlike, I would say, the commercial space, the open source space is somewhat, a little more complicated. It's fragmented. And typically with commercial tools, you can either separately procure or you'll get a data set that goes with it. That's another issue with respect to open source modeling. All the tool developers we speak with, they're like, oh, well, the big thing we spend a lot of time on is like grabbing the data we need, cleaning it up, getting it ready. So that's another barrier. And then lastly, user friendliness is an issue unless you've grown up, programming at, a terminal line. You're probably not going to be able to access a lot of the open source tools that are there, whereas a lot of practitioners are used to really fancy GUIs, right? They don't need to have programming skills. Just to be respectful of time, I'm going to sort of jump to the bottom line. So there are all these challenges, but there are ways that we can overcome these barriers. And that's what we would want an open source initiative to do. So for example, in the context of trust and credibility, what we're going to need are activities where we benchmark tools. We benchmark open source tools with commercial tools. We have these sort of intermodel comparative kinds of exercises. We've started to see some of these things happen. That's one way to build trust and credibility. We need to have a standardization of open source data. That's really sort of, in some ways I would say it's really the tool and its data sets. They're both sides of the same coin. So that's something that needs to be tackled. One of the value propositions is that you can have increased flexibility with open source tools. So to the extent open source tools are bringing the capabilities to model resources that the other tools cannot model, then that's going to be an advantage to the users. Is it capable of modeling multi-day storage more, accurately than the other tool options? So we came up with these different pillars. I've spoken to most of those pillars already, but the last one that I want to mention is that what I think is going to really take this, up to the moon is if we can create a sort of environment that fosters a community of both development, so we call it a community of talent, and that's both on the development side, so that different developers are working with each other and sharing ideas, and really sort of, continuing to move the state of the art forward, but then also can we expand the talent base on the user side? Because this has to get beyond academia to really be able to have an impact in the actual field. And there are some examples. There's one example sitting here at our table, two examples actually, where we see the use of open source tools, but it has to go beyond just California, for example.
Let's save some for the discussion.
Okay.
Okay, thank you very much. So if you were paying attention, you probably realized that Priya has a PhD from Berkeley, but you might not have realized that she was at General Motors when it rolled out one of the first mass-produced electric vehicles. Now, Max Parzen, our next speaker, once worked at the R&D center of Porsche. And he tells me he drove every fancy car there and discovered that they all have 4 wheels and 1 steering wheel. Okay, so Max is co-founder and CEO of the nonprofit Open Energy Transition. And before starting OET, he got his PhD in energy system modeling at the University of Edinburgh, where he contributed to PSA Earth. And he just recently bagged an award from Europe's Energy Storage Association. And Max is going to talk about sort of closing the feature gap and supporting adoption.
Awesome, thanks. Thanks, Peter. So I'm actually native German, I would say. So let's just keep that in mind. I'm not from Edinburgh. Basically, often people ask us, okay, how do we earn our money and what we do and that kind of stuff. So I'm just briefly introducing that and also giving you some insights on what we do. Basically, like a nonprofit really works like a profit company in that sense that we also need to make money and get revenue streams. And basically how we do that when we started like 5 months ago, and we just have now like about 13 people, so drastically growing. How we get our revenues through like studies, consultancy in a way, software development, maintenance, and training and support activities. So because we're a non-profit, we don't have access to VC funding. People complain often, okay, Max, I want to invest in your company, but I can't. Like, if you know, then in the other way around, like we have access to that, like philanthropic funding, just let us know. We have cool ideas. Hopefully I can convince you by the end that there are some cool thoughts out there. So what we're really aiming for, 2 things. So we want to actually close once the feature gap of this open source tools. When I was speaking with users from the Plexus world, they basically, they're actually quite happy. So they say, I don't need like anything else. Like I have all the features that I need. But then what they're also saying is, okay, there's one feature missing, and then that's like the open source nature. And I think they can never have that with this closed modeling tools. So there's really no choice on like sticking with that around. The second point that we're working on aiming for is exactly what Priya said, the point on widespread adoption. So like we need some kind of institutions to back up this tool developments, support people, really holding them at the hand, bringing these tools out, and helping them to transition really from this old standard, I would say. And then, yeah, also the marketing aspect. I think the commercial tools are just, they have more resources to do the marketing properly. Yeah, I think what's really cool is open source just doesn't allow to do the same things as before. It actually, like, it creates new solutions. So I would say we are actually not a competitor, let's say, of Plexos, but we are actually like a kind of next evolution, because we can actually not deliver only numbers, but each of us, we can deliver numbers plus the code to reproduce that, which is a completely different product. And in that sense, I would say, like, like this closed models, like the kind of Nokia, the old ones. Like I'm also a little bit older, so like I had the experience with this non-screen phones, and I think we are now the kind of. I think the open source is a kind of Apple in the space, like where the next generation of tools is coming out. Yeah, and we're actively working on that. I have a couple of projects in that sense where we help people to transition. And I think this is just something I want to underline, that there's really a need, so I'm just repeating myself, there's a need to support people to transition. When I was speaking with several TSOs, like I would just frame it in one sentence, it's like they thought open source was a blessing, but in their case it actually turned out like a curse. And in that sense, like what happened here is that they jumped into open source tools, picked one with a small research group, which is already great that they're using open source. That's a cool motivation, new solutions, new things are possible. But what actually happened then in their case is that they were missing the support. They were missing features, and like if you're a transition system operator, you're actually risking not delivering your reports in time. So is this the 1 minute wave, or?
It's the 30-second wave.
30 seconds wave, all right. Yeah, so Priya's just laughing now.
25 seconds.
All right. All right. Yeah, I think that's it. Like, let's just. I think like something what's now happening is that we're trying to build up these institutions which can support industry. And I'm excited to be in one of those companies to do that. There are many others out there as well. And yeah, I'm just handing over to Peter again. Thanks, Peter.
Okay, thanks, Max. So our next panelist is José Daniel Lara, another Berkeley PhD plant. And he hasn't disclosed his automotive, colors yet, except that his love of cars is very serious. He's a big fan, and he admits that even he finds that a little weird, since the internal combustion engine is a climate killer. So José really has, a lot banking on decarbonizing cars. Which of course means decarbonizing our entire energy system. José is a senior modeler at NREL's Grid Planning and Analysis Center, and today he's going to be talking to us about Sienna, a plexus killer, perhaps, and about how NREL has worked to design that system so that it is more accessible.
Well, thanks. As Peter mentioned, I come from NREL. We have this tool called Sienna. That's basically a collection of actually Julia packages. I think it's the only tool that doesn't try to touch Python. And I'll explain why in a moment, but not to repeat what Max and Priya already said, Sienna has all of the principles you guys are mentioning, which are really important, like openness and allowing people to have access to better tools when they can't and so on. But we also have two additional elements that for us are really important to bring into the table. One is rigor. Simulations in the energy systems tend to be very non-rigorous. There is no actual determination about, for example, if you go to the simulation space in differential equations, there's a lot of rigor in what that implies, but we don't have that for simulations that we carry out in the energy system. So a lot of our effort has been to formalize the notions of simulations in a way that they're tractable and that the results actually are consistent with, for example, time consistency, right? Are the actual results, when you need them to have the rigor that you require or the variables correct and so on. So that's one of the things that we care about. The other part that we care about is creating an ecosystem that allows to think about simulations not as something that you run once, but also include components of computational experimental design. Like if you go to other fields like computational genetics or computational biology, there are very strict rules about what it implies to have a simulation, and if you submit a paper, what is reproducibility, what is the data, how do you run it, what are the variables. And because a lot of the sciences come from the bench sciences, they have better ideas about how to design an experiment. So on top of all of the elements of openness that we want, and all of the elements of, we want better access to some tools and have more flexibility, there's also an element of how can we have better results, right? There's a bias sometimes towards thinking that the current state of the art is what we are trying to do as open source. We want to match Plexos or match PSCC or match something else. But in fact, we want to supersede them philosophically beyond that. So we don't even need to try to match against them. Of course, there's a trust element that Priya mentions, but my argument has been that that's an ill-posed question and doesn't deserve an answer because you're assuming already that this is the correct solution. And if your tool A is the correct solution, you're trying to match B, all you're doing is replicating the outcomes of A onto B and not thinking about how can B be a better solution. And that is actually a pretty well-studied phenomenon. It's not something that just comes out of I'm saying this because I think that. There is this idea in software engineering that organizations will replicate in their software engineer practices, their communication practices. And what happens is that even in the open source and in the industry, we all think about sometimes as utility or as a regulated group, which implies that we end up building software that replicates those communication structures and those practices, even if they're open source, even if they have a new code, even if we do something fancy with some language to make them better. So Sienna comes to say, how about we challenge every single assumption as we build the code? How about we challenge every single way of doing things as we try to put rigor into it, experimental design into it, and we learn from other fields that run admittedly more complex simulations than the grid simulations that we run. And in that way, of course, create some challenges because you at the same time, you're trying to make people to use your open source tool, but also telling them the way you've been doing it for all this time is wrong. And that it's a problem that we have, and this is why some of the issues that we face is users don't understand how to use it because they expect something that they've done for a long time, and the whole point is you don't need to do that, right? It's someone who's been only eating McDonald's, and you're you can have filet mignon. There's an option. You can do something else that is not eating this crap. So I'm speaking very frankly, that's one of the things that we want to do across the board in timescale. So we've managed to actually do that in dynamics. We have shown to be able to match industry tools for over 1,000 times faster simulations because we apply different mathematics that allows us to match that. We have done that in the PCM space because it allows us to also use other techniques and other methods. It allows us to run the largest PCM in the world right now, which is the whole US at the nodal level for the NTP project. And the next challenge that we're on to is we're trying to now redefine how do we do investment and expansion planning based on the same principles. How do you challenge the assumptions that are embedded, even if it's open source? I would like to tell everybody who uses open source and develops open source, think about if what you're doing is replicating existing practices that might be outdated in principle, even if your code is open and in a fancy language. And the last thing to mention is, when you choose a language to program, stop using Python. You cannot use a language that doesn't use mathematical elements as a first-class citizen. If your language doesn't have matrices, vectors, and proper mathematical management tools, you will always be kind of working with a hand behind your back.
I disagree, yeah.
Thank you. I think we better move on quickly here. That was actually the second most controversial thing I think that I heard you say, Jose. If I'm not mistaken, you were encouraging beef consumption there.
No comment.
So next up, Neil Raffin is a senior regulatory analyst at the I'm showing my colors here. The California Public Utilities Commission. He's a math guy with a background developing energy projects on 4 continents, and he kicks off our third panelist backstory theme, which is the stealth journalists. Neil admits to, before moving to California, having attended a solar conference here on a press pass.
That's right. Good morning, everyone. And my article on rooftop solar went unpublished.
Okay. Well, don't give up. You know, it takes a little while to establish yourself. I can give you some pointers if you want on that. Anyway, so Neil works at the CPUC's Integrated Resource Planning, or IRP, process, and he coordinates reliability analysis for that, and also the Commission's approach to procurement for reliability and greenhouse gas reduction. He's going to talk to us about, among other things, contributions of modeling-able stakeholders.
Thanks, Peter, and thanks so much from Max and Cameron, the other organisers. It's great to join you. I know it's quite an international group, so just quickly, the CPUC is the utility regulator in California, regulating monopoly utilities, including in electricity. And in electricity, the CPUC also has authority over non-utility providers. So basically, around 45 different electricity retailers, think of it that way, is the regulatory authority of the organisation I work for. And yeah, I work on integrated resource planning, which is used globally in various places, and IRP, as we call it. I'd say we've got a reasonably unique implementation of it here. A couple of things. I mean, it still attempts to do the sort of apples for apples resource comparisons for our future, to meet our future electricity needs and GHG reduction goals reliably at least cost. But perhaps one unique feature is the prevalence of load-serving entities, or those retailers, and their planning, their plans in the process. So it's not a fully centralized planning process. There's very much a bottom-up approach, which I think you'll hear more from Doug about, representing one of the load-serving entities. And so anyway, the outputs of our process, we create planning portfolios for the future, which then go into the transmission planning process, so it can result in new transmission lines being approved by the CAISO, our planning partner. And then the other piece the CPUC is looking for from our planning is where are existing markets and programs not sufficient to deliver the resource needs of the future. And so where might the CPUC need to take additional action? So those are kind of two key outputs. And it's, I think it's quite interesting when you think about the modelling background of this is the procurement world, the CPC tries to be technology agnostic. So our modelling, we very much care what type of resource is it, where is it, what size is it. But when it comes to procurement, we're really trying to think about how to influence industry, operating in a competitive environment to make its resource type choices. And that's the general approach. There are some exceptions. And just to give you a flavour for our current work, we just put out a proposed preferred system plan, which the likes of Doug and our stakeholders are writing comments on, and we're going to get those today, so we'll hear what CAISO stakeholders... We basically cover 80% of California's load, the sort of planning work we do. So that's the live topic. It'll influence what we study next in transmission and potential procurement. And in terms of our modelling, we've got two types. I think Cameron, who spoke earlier, his work kind of does what both of our models are trying to do. We've got our production cost modeling, and including reliability analysis, and then we've got our capacity expansion modeling. And I think we kind of actually take a bit of a mix of approaches in terms of open source and commercial. The production cost side, we've got, what we're trying to do there is reliability studies to determine reliability need and resource counting to use for that, and then we can use that in our capacity expansion modeling. And we're also studying our portfolios for their emissions and reliability in more detail than we do in capacity expansion modeling. We license ServM for that and engage the vendor there to support us, but we do have in-house modeling team running that. And then on the capacity expansion side, we've got, I think this group knows well what that's all about, exploring the future of our grid, taking the existing, and it's a zonal model we use, Resolve. It's open source, but open to hear how accessible it is from folks. Yeah, it's a zonal model, so but then it's important to realize we then have a very important process to map those future portfolios to bus bars so they can be used in transmission planning. And that's not a modeling exercise, that's very much a sort of people exercise. Thanks, Peter. And yeah, so stakeholders are central to our process. A number do their own modeling. Obviously, the load-serving entities do that to varying degrees, depending on their size. But we also have stakeholders doing their own too, to be able to contribute to where we want our grid to go. And our sister state agencies do it, like the CEC, as well as the CAISO, and we collaborate with them to try and have relatively common approaches and inputs to then gain more meaning from the modeling results. Yeah, I think that's a good place to leave it, I think. Yeah, it's a very public process, and so I would welcome folks who are interested, if you're not already, to participate in our planning process.
Okay, thank you very much, Neil. Our cleanup batter today, Doug Allen, is a modeling-able stakeholder. He also cements our stealth journalist theme. Doug joined the energy sector in 2007 when he worked at E3, also with Priya at the time. And then he told me he took a short break from 2011 to 2015 to slowly drop out of a PhD program in communications. Okay, so then he left E3 again in 2019 to become modeler-in-chief for the East Bay's community-based clean energy supplier, Ava Community Energy, where he's responsible for building the company's analytics platform. By the way, last week NREL named Ava one of the top green power providers in the US. And Doug's going to tell us how they used open model software GridPath to complete their IRP.
Yeah, thank you, Peter. As you said, I'm the modeler-in-chief at Ava Community Energy, formerly East Bay Community Energy. We had to change because we're expanding into the Central Valley. Our experience with open source really started with the IRP cycle of 2022, is that right? The last full one? Where we put out an RFP, and a pretty important consideration is the CPUC has a lot of requirements for what a conforming plan is, and we need to respect those. We want to be a good kind of member of the planning process and make sure that whatever we submit is really tailored to those needs, but we also wanted the flexibility to start focusing, and really what I'm trying to do is turn the IRP into more of a continuous process within our company. And I thought one of the reasons that we went out looking for an open source model was we really want to kind of bring some of that in-house, have somebody who's able to use that tool, but also be able to kind of direct the development a little bit more. And I think you see that with, all of these different modeling platforms none of them are really, people try to make a one-size-fits-all, and they're never really that. So I think the open source, and we already saw that, we're working with first principles using Blue Marble's grid path. We were able to say, okay, we want to focus a little bit more on this during this current planning cycle. I think at that time it was the resource adequacy and how our long-term contracts affected our procurement. And going forward, it's going to be more focus on the slice a day. And the ability to kind of direct that, I think, was a really big impetus for why we wanted to go with an open source model when we were selecting that. On top of that, I think you really have, I am fortunate enough to be at an organization that is pretty well resourced, but a lot of our kind of sister CCAs across the state are not as, don't have as much bandwidth to do some of these things. So as a nonprofit, a government agency, we thought it was really important to maybe try to take the lead in saying, hey, we're gonna get out in front on this, and we're gonna start working on some of these things that are responsive to the very specific planning context that the CCAs are in, that, we need to be doing slice a day, we need to be thinking about these things. And also, is expandable into the specific challenges that all of the CCAs face. Different CCAs have different timelines for how fast they're going green, whether they're doing 24/7 matching or not, and all of these things, require a little bit different tools. And so I think that's been a real kind of drive for us to be using the open source modeling. I think the other thing that I would just say as a kind of long-term participant in the energy modeling space, specifically in California, I think it's really exciting, even though maybe we're not supposed to use Python. It is really exciting to see, I think, more and more young hires coming that can actually do some of the programming, whether it's in Python or in some other language, because one of the first things I did when I was hired out of Stanford in 2007 was kind of rebuild the RPS calculator that was used to identify resources for kind of where we were going to build transmission in California. I don't believe it's used at all anymore, which is probably for the best. It was technically an open source model. You could go in, you could look around the Excel spreadsheet, which I think got up to like 50 megabytes, which is way too large, and you could ostensibly follow the work that I had done. It really wasn't. I think it was referred to at one point as a spaghetti model, which I think is a very generous description. It's, if you were not me, you probably didn't understand how it works. And I think going forward with more of the kind of programmatic, like really actually software packages, there's a lot of opportunity for people to modularize these things to the extent that you can start actually saying, okay, I just want to mess with this little piece. And here's where I find it, here's what it does. I want to change it so that it takes this input and produces this slightly different output, where before I think that was a lot more challenging. And so I'm really optimistic about the opportunities for that kind of confluence of expertise and available languages to make this a lot easier and make these tools easier to adapt to different needs.
Okay, thank you. Great intros and pretty good timing. You get B's. Priya, I wonder, since I'm a storyteller, I wonder if you could give a real-world example of where sort of an external stakeholder was able to use an open source tool that might exemplify some of the sort of potential and also the challenges that you identified in your report.
Any kind of external stakeholder?
Okay.
Well, actually, I'll give one example. And this is also something I wanted to kind of share earlier, but speaking of modeling resource adequacy and using open source tools, about a year and a half ago, we released, using GridPath, we released what we call the GridPath RE toolkit. So effectively, it brought in some algorithms that allowed you to do resource adequacy modeling, which sort of builds on a sort of simplified production cost modeling framework. And we created all these data sets, we made everything public. And that was, ostensibly a research study for us, right? And we don't do too many of those that are just because we want to do it. There's always a typical client in mind, and in that case, there wasn't. Since we've done that project, we have had at least one concrete request from an external stakeholder, nonprofit organization, unassociated with that project, that specifically contacted us with the request of using that platform for doing resource adequacy analysis in another Western state. And they wanted to work with not the person that developed that, open source tool, but an entirely different technical stakeholder and expert. And we're at about 90% through the process. And I would say that you wanted to ask about pros and cons, right? So pros is that they could just pick it up and run with it because, they're, as Doug was talking about, some of the younger talent has the programming experience and some of the ease of navigating these platforms. In terms of a con, you never really know exactly what's in there until you start looking in it yourself. And so it's not quite fair to say it's a con, but definitely there's a learning process in taking, anything that's not sort of straightforwardly organized for you to understand every single aspect of what the guts are in that tool. So it's a little bit of a weak con, but yeah, there is still a little bit of a deficiency there, I would say. And yeah, there are other examples, but I think that.
Thank you very much. Other panelists, any sort of real-world examples of someone sort of coming from the outside and being able to grab one of these tools and get involved in the process of planning the energy system of the future?
Well, in our case, we have, for Sienna, recently, we have this network of Latin American countries trying to do resource analysis, and it's a very different context. If they're badly resourced some CACs here, you have to see what Honduras, Costa Rica, Republic Dominicana have in their toolkits to do modeling, right? And in the last month or so, we've been able to deploy solutions to 3 of these countries where they can actually, we built a little bit of a nicer interface still, but we've been able to basically follow the process of creating a mechanism for them to build their data sets. Once the data set is built and validated, they can run their simulation. So the relatively small problems with the small systems, but they have a lot of value for those stakeholders. And on the other end of the spectrum, we have, for example, the PR100 story. It's a study that is almost $70 million worth of studies to figure out how Puerto Rico can become 100% renewable. That has a huge element of stakeholders wanting to understand because of the institutional problems of Puerto Rico post-hurricane. And we were able to deploy to the myriad people who wanted to figure out, because of trust issues in there, solutions that were open source so they can study and understand what the more than 168 scenarios were of different technology mixes. Some stakeholder wanted something super weird, and we have to incorporate it. And basically, how do we deploy those situations where there's a mix of highly technical work, because the getting an island to be 100% renewable require very highly technical modeling, plus a lot of demands from stakeholders to understand what was happening, plus being able to run multiple scenarios to comply with the principles of experimental design and rigor that we have. And that project is wrapped up, I think so by now, or the report is almost done. And it has actually shed light on a whole bunch of opportunities for Puerto Rico, requirements for the grid to be able to support those resources and so on and so forth. So those are the 2 kind of extremes of something super simple of high impact and something super complex.
Yeah, that's great.
Peter,
just jump in.
Just to repeat, the one open source example we've got currently is the Resolve model used for capacity expansion. And so I mentioned that, but just a bit more about it. It's on our IRP website as well as on GitHub now. And but we do certainly utilize the resources of E3, who are under a technical services agreement for the IRP process, covering other services, but supporting Resolve is one of those. And so, that's a consideration. Is that an example of open source as we think about what might be available in future? Who do we go to with problems with the program or necessary improvements to keep pace with the decisions we need to make in the resource mix?
Yeah, like just a few words from this unpopular Python language. Like we can linger a little bit about it. Like
I forgive you. It's okay.
So basically, in our Python world, I think we have around like 50 use cases or something like that where people just adopted the tools. Like, I mean, even beside outside of this research bubble, like outside of our cases. So we see the tools being widely adopted, and it's also sometimes, as Priya mentioned, some kind of Wild West. So it's like sometimes you don't see what people are doing exactly with it. And in one case, for example, that's very cool. It's a case from Amber, an NGO in Europe. They really used the model, shared the whole study afterwards, which I think is quite leading. But they, for example, could also improve in using some of the existing workflows and data streams that are out there. So, like we see some cases of that. Sometimes we don't see really what's happening. We just see a study from, I don't know, Tata Steel, Shell, or someone else. Like this is often what we see, just reports. And then in one case, yeah, like we're working now with the TSOs as well to just improve actually their setup, what they have behind. So because I mentioned it's the Wild West, what they actually do is then implementing it in a way that takes a lot of work to actually continuously update it or to even contribute to the open source world. Like we're just helping them making most of what's out there.
Doug, you're the only panelist who hasn't weighed in here. Do you want to?
I mean, a real-world example of using open source software would be our 2022 IRP. So, which I think, it went really well. It went actually smoother than some past IRP experiences we had with more kind of proprietary language with actually a much smaller and more streamlined team. So, I think there's some real advantages there.
Interesting. Okay, I'm going to throw it open to the audience in a moment. But first, can you, whoever wants to jump in on this, are there real feature gaps that still exists for open source? Are there still places where there really isn't an alternative, a credible and trusted alternative to the proprietary world?
I'd say that probably on the scaling is one of the biggest gaps. Like, if you actually say, I want to run a full nodal WEC in open source today, even without our tools, where we have the backing of DOE to develop those capabilities, you start seeing like, okay, where do the problems start to happen, and how much effort has to go into scaling to real-size problems that you might expect, for example, MISO to run or PGM to run, right? So I think that there is a major gap there, and one of the biggest challenges is that there's a whole community of operations research that has those techniques and a community of modelers, and the gap in between those techniques is very expensive to close. At the lab, over the last year, I don't know how much money has gone into creating the capabilities to run the whole Eastern interconnection as a single nodal system, right? It's a system that is so large that it has more than 1 billion non-zero entries in the A matrix of the optimization problem, which means that the solvers themselves cannot actually hold the A matrix to do the LU decomposition. So that's when we get to that size of problems, then the requirements that jump in complexity both on the software development, the mathematics, and the cost of hiring talent that can operate at that level probably, will make it really difficult to productionize. So you can go and find someone who did a PhD on super large scale, LDMM, blah, 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 blah. But productionizing that technique into a software modeling that we can deploy, there's a huge gap that costs millions of dollars. And that's a big one that at least we observe. And we fortunately have DOE backing, but it still takes a year or two to even get there.
Add one additional point, which is kind of in the realm of being able to dealing with complexity. To this date, I would say there are no commercial capacity expansion modeling tools that allow you to go beyond just a sort of day sampling. That's sort of what the current generation of those tools allow for. Whereas in the open source world, there are a couple examples. Switch 2.0 actually can look across all hours of the year. I believe GenX does that as well. Grid path can be configured to be able to look across all hours of the year as well in that portfolio design step. So that's one sort of concrete feature that right now, at least, we haven't seen the commercial toolkit, tackling that challenge.
Max?
Yeah. I think, if you look at the Plexus results and what they're doing, I think many of our tools probably, we're also speaking here from different classes, we have to be aware that there are actually different tools out there, right? So you have there are dynamics tools, there are capacity expansion tools, production cost modeling tools, and so on. So just to clarify, I'm working more on this dispatch and capacity planning tools. Just from these classes on looking, for example, at Plexus, I think what we see is that we can come up with the pretty much similar numbers. There's no huge gap in terms of features. I think if there's any small gap, we have talented people that can just close that. I think one of the features I would say is the part of the usability. We need to improve the usability to have no scalability issues. For example, if you deploy a huge network, you usually run it on a high-performance cluster. You need a solver setup and maintain that kind of stuff. And in commercial solutions, you basically click on a button and it will be computed. So in the open source world, it's not like that. So I think from in terms of usability, with the maybe graphical user interfaces and that kind of stuff, I think this is where the main gap is on our side, from the feature side. But I also agree on the data. Practically all the models, what we do is we're filling data structure with new up-to-date data and then optimizing something. And I would say we are spending quite little time in Python. Most of the time, in an optimization case, I'm spending 95% or more, in C++ in the solver side. So could be more Python, but yeah. It's C++, unfortunately.
Doug and Neil, do you want to jump in, or should we throw it to the audience?
Yeah, I'll just say real quickly, I think and this is both a kind of opportunity, maybe it's a feature gap, but also an opportunity for filling in, is I think sometimes just getting the data together can really be a big challenge. And if you have a commercial tool, sometimes they will have preloaded packages. There will be, a more robust kind of support network. And so I think there's an opportunity there where if you can kind of get it spun up, hopefully, and what I'm asking my team to do is, develop those pipelines really for, here's what we need. Here's how we store our data, and here's a pipeline, so it's one click, all your input files are configured. But I do think it's a little more work than sometimes it might be with a commercial product.
Neil?
Yeah, I guess so. Related, this is not a technical answer, but so if we were to think about moving from ServM, our production cost modeling tool, to something open source, who would we go to get help with fixes or ideas to use the tool better? We're just coming from a traditional sole provider world, and I think it's not insurmountable, but that's a sort of natural question or gap you'd have to address.
All right, thanks. Okay, who has our first audience question? I guess I will. I'll do the Oprah thing.
Hi, thank you. This is great. I have a question for Neil. So you said one of your primary goals is to look at questions where existing markets are not sufficient and where the CPUC would need to step in to ensure reliability. And my question is, what are some examples of those situations, and do you have all the features you need to address those questions?
Yeah, and it may not just be to do with reliability, but that is a recent example where the Commission ordered, in total now, like 19 gigawatts of reliability capacity to be brought online from new resources over the next 4 or 5 years. Yeah. So then another example would be for greenhouse gas reductions, where we need to get to basically all our electricity delivered in 2045 to be from zero emissions. So we've got the renewable portfolio standard now, which gets us 60% renewables by 2030, but that won't get us to zero emissions by 2045. So that's an example where, okay, there's a gap there. We can model what we need to do that, but then, yeah, the procurement action is a different matter. That's.
So you have the modeling tools you need to step into those situations, or?
Yeah, I mean, right now, we've got a view of like what resource mix of solar batteries, existing gas, imports we need to get to 2045. It's up to debate whether that's right. Of course, it's a forecast, so it's wrong. But yeah, when you think about how to turn that into procurement, there are considerations like which of those resources could be procured without the CPC stipulating that type of resource. Which ones can be reliant on just you set the high-level attributes, and then the industry goes and figures out the right resources to do the job. So I'm sure modeling plays a role there, because we already have like a paradigm of measuring and optimizing around certain metrics in our model. So we've got to keep an eye on, are those appropriate? Are they going to bias towards or away from actually what's optimal? So it's a good thing to keep in mind. Thank you.
There seems to be a proliferation of open energy system modeling tools. And if we think of a taxonomy of energy system models, I mean, is it good to have 1,000 flowers bloom, or should there be a process to coalesce around a small number of models in each category? And if so, what kind of process would lead that coalescing process?
I can try and tackle that. It's a really great question. I mean, interestingly, when we started looking across the landscape of, and this was part of the eLab initiative I mentioned, it seems like in the open source world, at least, there are a lot of capacity expansion modeling options. When you get into production cost modeling and resource adequacy analysis, the pickings are more slim. PIPSA is one of them, GridPath is one of them, and I guess NREL has various tools as well. But I mean, at least from our perspective as being users and trying to find the right tool, we don't have a lot of options in those other two sort of functions when it comes to bulk system resource planning. Would it be better if there were fewer options? I mean, I think that, like, who would be making that decision, right? Like, ultimately, it would be either, I guess a funding entity, right, that's supporting open source tool developers, and I'm not so sure we're at that place where we would want to pick a winner or a few winners as a community, because I think these tools are still evolving, and we're still trying to figure out like what additional features we need to bring in. So right now, at least I feel like if the community can more coalesce around, you know, things that will help everybody, like, you know, figuring out, you know, and developing publicly accessible data sets that all modelers can use. I think we can move forward, you know, farther and more efficiently.
Like just a little comment here. I think like every penny that we invest in open source, I think is better than the alternative route of black box modeling. So, like I see also, you know, like a lot of investments in different directions, different tools, and I'm not so like jealous about anything when I think, like they didn't pick our tool. Like we're more actually trying on the open source side to lead by building, you know, creating solutions. I think everyone tries here really hard on, you know, like pushing the boundaries. And I think we always have to think, okay, we are like one community, and actually, even if someone else gets the funding, it actually helps our mission. And so, yeah, just, you know, keep your cool work going here.
I'd like to give a more pragmatic answer to that question, and it's the fact that given that the funding agencies and organizations that go into the open source tools have their own priorities, and that dictates to a point the priorities of the different open source tools, you want to have 1,000 flowers bloom because, you know, whereas, for example, we spent a lot of time in Sienna thinking about reserves and deployment of reserves and how do you model multi-stage markets, we haven't done the work that PyPSA has done in the expansion side, for example. Because the priorities that have gone through the funding that we get had said, we want to get really, really good at understanding reserve requirements for 95% renewables. So we want to get really, really good at understanding inverter requirements. Whereas another tool, I don't know, the GenX has focused a lot in understanding how will it work to have different like tax incentives for the expansion problem. So I think that there's an element of like, if we were a single company, you can have different divisions working in all of these features as a single monolithic solution. But the reality of the open source is that all of our funding streams will push us towards particular uses that then, when the need comes, for example, Open Energy Transition says, well, I have a client now that wants to use PyPSA but requires some inverter modeling. I don't know, I'm just coming up with something. Do you have an option that is specialized in that where you actually then leverage the things that you specialized on the expansion side and stuff like that? So I think that there's an element of pragmatism about like why do we want so many tools is that, you know, funding agencies will have different priorities.
I think we had a question over here.
One of the gaps that got mentioned a lot was the lack of usability and the need for better user interfaces. But when I every hour, I guess. And when I think about these open source projects, like you never really, you know, you have a lot of talented modelers and mathematicians, but you never see a UX UI person on those teams. And if it's, you know, maybe you have the best mathematically, you know, complex model in the world, but if it's hard to use, is anyone ever going to use it? And like, if it's hard to use, is it truly open in spirit,
Yep.
even if it's open source, right? So like, what do you think can be done to close that gap in, like, or is there a need for like a subset of open source GUI tools for open energy modeling? Is there just a need for every project to have a UX UI person on the team? Like, what needs to happen to close that gap?
So I think that, in my experience, that this really speaks to the importance of, again, this kind of younger than me group of talent that is able to actually go outside of spreadsheets, copying and pasting, and start to set up. You know, I think when you get even a fairly basic proficiency in a programming language, you can do a lot of the kind of data manipulation and preparation things. And that's where I think it actually is very useful to have the open source where the focus isn't on UX UI in that specific way. You can, you know, again, I want my team to tailor it to, here are our needs, here are the scenarios we're gonna need to run. And then we we just have to get it to that starting point. It's like, all right, files are in the right format. And I think I am optimistic about the kind of capabilities of kind of getting rid of some of the GUIs that are necessary, because there's more understanding of the actual data and how it flows through systems.
Yeah. I'll just build on that. I think it's a great question, and I would say that it speaks to a more general one, which is, you know, are these tools usable, right? User friendliness, and definitely user interface GUIs are one dimension of that, but it's not the only dimension. And one of the things that we hear a lot about people trying to then take on another existing open source tool is they just don't understand, the documentation is very limited. They just don't understand what's going on. Like Doug gave the example of the RPS calculator, open source, but no one would ever know what was going on unless they were him, right? So I think to the extent, as we're developing these tools, there is an emphasis on making them such that maybe not someone who has, you know, the user doesn't necessarily have to be someone who has zero skills, right? Zero programming skills, or needs a really, you know, clear GUI, but someone who has that background, but then the tool itself and the documentation that comes with it, and, you know, using comment lines and things like that, make it such that others in the community can access. I think that would go a long way. And we talked a lot about data being an important thing for usability too. That's a huge barrier to access. So at least we're definitely, you know, looking into different initiatives that could help sort of break that barrier, the data barrier.
Awesome. Like, just one note. I mean, just to answer your question, I think so far it didn't happen so much, you know, like the DevOps solution for quick computing with one click and so on. Like that didn't happen because it's not, you know, like a researcher's task to deal with that, where most of our projects are coming from research, really. But what's funny, like even for Plexus, you know, like when I speak with people, what I learned then is that they actually work, like they create workflows around the Plexus engine. So actually you need coding, like you need to be skilled to do it. So it's a way like you know, like you want to buy a dog and you get a cat. Like this is just like, I'm not sure if that was a great example, but but I mean, like you buy something, you want a solution, but it's not really holding the promise. And yeah, like this is actually what I would say. Yeah, like even that. Like, do we need all that features that these tools are offering? I mean, sometimes no.
I mean, I'd say that there is like a big of a fallacy in terms of like having that the fact that a tool has a GUI makes it usable. Those are not two equivalent statements. And on the other hand, there's an element again of scalability. If the fact that you can open in your laptop and hit play to run a 5-boss case or a 10-boss case or an IRP for its 5, you still need then compute to actually run complex cases that we need to run. So when you say this tool is usable because it has a GUI, it's Windows only. If I want to deploy this in the cloud or in HPC, I have to go and put this into a virtual machine and put it in a Docker and put the thing, and like the amount of hacks that you start building on top of the fact that it has a GUI makes it worse. Because then they support the single operating system, it's not multi-platform, and then you're suffering more because the moment that you have to scale. So sure, there is a problem with the GUI for the first-time user who opens you know, Joe in PG&E opens the computer, 50 years old, has only used Windows, wants to click and see a result. Joe is the problem. Whether like the new guy or the new person in the utility who knows how to do this and knows how to roll AWS, that's the person who actually goes and says, okay, I understand how to run systematic code. I understand how to actually use these tools better. So I think there's a fallacy again. GUI doesn't mean usability. And sometimes it's even worse that it has a GUI because it becomes single platform only. And that creates a problem to scale analysis.
Yeah. This was actually one of the points that came up in our initiative as well, in that you add the GUI, and oftentimes that sort of putting you into a particular corner in terms of a use case. So it can take away flexibility as well.
You've met Joe then.
Pardon me?
You've met Joe then.
Is there a need for benchmarking more benchmarking exercises, and or is that already happening?
It is. I'm going to take, and I want to respond to a very valid point that you made, which sort of I think is worth discussing, which is that we mentioned that in our activity, trust and credibility is a barrier. It's something we need to address. Benchmarking can be one way of addressing that. I have seen in the real world that benchmarking between plexos and, say, GridPath has been one way to build credibility with different users, especially grid operators. Now, your point was a very good one, which is why are we, trying to compare a commercial tool and an open source tool when the commercial tool can't even, it doesn't even have those certain capabilities, right? And you're right, there's certain kinds of problems that you don't want to challenge both tools to, but you can pick a particular problem, a simpler problem, where you're really just trying to validate, okay, in this more simplified world, simplified system, how does this tool compare to this tool? It's a basic kind of QA, QC kind of approach. And we can probably debate about that, but just from a pragmatic, practical perspective, not in the research world, but in the world of trying to get regulators or getting utilities, and I don't think your utility is the typical one, right? This is going to be one element that I think is critical. And we're actually getting these requests from different municipal utilities and other partners that we're talking to.
Yeah, I would say for us, benchmarking is extremely important because he's going to be very unhappy if I give him something that just does not fit, right? I think there are, and it does not help the state. And I think, we really do want to help accelerate the clean energy transition. So some ability to say these results are reasonable or not, and whether that's like an hour-by-hour matching or some bounds. Sometimes benchmarking can be as simple as like having somebody who kind of knows what's going on look at it and be like, okay. But something that allows these different tools to answer the same question without really putting us at loggerheads saying like, oh, my tool says we're going all in on offshore wind, and my tool says, given the same assumptions, like it's terrible. That's a problem in the kind of real world planning environment.
Like, you want to go first? Yeah.
No, go ahead.
Okay, like I'm just saying on the topic of benchmarking, I think some cool stuff can come out, and probably like you're also going in the direction that this is not always useful.
It's a waste of time.
Yeah. So like who worked on benchmarking? Like, did someone work on benchmarking? Here. Me too. I think at the end, like you cannot really benchmark all the features. Like this is one problem. I think it's a lot of hard effort to get it really done. So it's taking as much as doing a study practically. But there can be also something good coming out of that. I think trust building is one point, but also building like interfaces to, let's say, different toolings. I think that's the only benefit that I saw from the whole benchmarking thing. Otherwise, I mean, in the best case, it's just math what's out there. And all the tools is a convex problem, we should end up at the same solution. When there's different solutions coming out, something is going terribly wrong. And that's probably, like this solver start or something like that. So, I'm not sure. You have some extra points here.
Yeah, I mean, the reason I think it's a waste of time, besides making a joke about it, is that the fact that when you can benchmark about 5 bosses, it's a benchmark that it doesn't matter. And once you get actually to a larger data set, you don't even have to get to the thousands of generators. Then the mathematics start to play. What is the degeneracy of the cost functions? Actually, Saurabh over there from NREL has worked, I don't know, how many hours have you invested in benchmarking against Plexus? There you go. So he did 3 weeks, I did 6 months. And the problem is that then when you start getting into the technical details about why these tools are giving different results, it's extremely difficult to control. So there's an element of like, if we're going to benchmark, we're going to have to come up with a case that is kind of like solid, that we know there's no degeneracy in cost functions. There is no like, but this has to be synthetic. So when you say, can you do the same thing for California? No, you can't. The data set from ADS, for example, to run a nodal data set is full of noisy data that will generate into tools very different results, not because either tool even given playing to the benefit of the doubt is wrong, is because the data itself would create situations under which the mathematics will reach to a different solution. And if you're going to do benchmark just on like someone, making an eye look into the results, I'm sorry, but that's not benchmarking. And that's okay. But, and some regulator can be happy with just that, but then let's not call it what it's not. We're comparing results to see if we're happy, fine. But benchmarking requires a particular set of metrics, and happiness of the regulator is not a metric that we can actually use to see if the benchmark worked out. So that's why I think it's a waste of time, because if we have to do it right, it will never actually create trust, because we have to create a synthetic system to create mathematical conditions to proper benchmarking. And if we do it like the way that it's practically done, it is actually not a benchmark. It's convincing someone that my results are not wrong. And that's a very different exercise that is more political than actually like objective.
I think
not a big one. Just that way of thinking.
I think, it's a little bit different definition. Like, again, for me, if my model produces something that does not fit in the state plan, I have not done my job. So there is a benchmark there where I cannot use something outside of those tolerance.
I'm just gonna take less than a minute.
Can we give Neil an opportunity to explain why his happiness is important?
You're the benchmark, Neil.
Yeah, no, I define my happiness in terms of a number, which is the reliability standard of 0.1 loss of load expectation. So yeah, we try to have objective standards for load serving entities to meet, and that's what Doug was referencing, because all of them are coming up from different approaches. So we set a relatively simplistic reliability need and resource counting for them to prove that their portfolio was reliable. Yeah, but I think Jose's point, it must be a long conversation, but I think it leads to questions like, well, what does a planner do with different model outputs then? I think it's great to have diversity. We certainly value that in our proceeding, in planning, like from a range of topics. But when it comes to modeling, I would think our decision makers would think that's less of an area where diversity, we would need to help our decision makers through what to do with such different results, even with the same inputs.
We're going through this with not open source tools actually, but with a client that's trying to pick between different commercial tools. And you're right that sometimes it's a mess because you may not even, and it's a difficult process, but there is sort of, an upside of that, and that you can use that process to better understand what is actually going on in the model. Is it calculating, marginal ELC, average ELC, et cetera, et cetera, et cetera. So certain things that maybe you didn't pay attention to that were more black box, so you treated them as a black box phenomenon, you need to now understand. And as much as we could probably argue on the merits of how to do it, unfortunately or fortunately, it is going to be it's a human nature to try to understand, if I'm doing something right now, how do I switch to another option? And there has to be some sort of way to build comfort that goes beyond, this developer has a certain level of credibility or certain chops. It's just not going to cut it for most practitioners.
You went first, Priya, and I think you get the final word as a result. Thank you very much. We haven't gotten to the bottom of some of the potential conspiracies that I identified at the beginning here, but I think we've learned a lot about open model planning, and thank this great panel for me.